Alright, so I dug myself into a hole with this code here. I mean, you can still check it out at SDF-017. However, some of the things I would like to implement and some of the insights I've gotten from kind of like casting rays into a voxel space make me realize that I need to rewrite this from the ground up with some of the new considerations I've realized. First of all, I realize you can recursively, not recursively, but you can nest as many levels deep as you want with this pattern, right? Where you have this voxel that's filled with pixels, and you march into the voxel, and then you march. Once you get to a certain pixel, you can march into that pixel to get a subpixel, and you can march into that subpixel ad infinitum. Now that conceptually you can just keep on going and going, but you have to have an end somewhere, right? Because we have finite resources, finite computation. I think that I would like to do something like that and have some type of generic marching code that understands where it is in the hierarchy of the, I guess we would call it an oct tree. It's not really an oct tree, but it's a similar concept to oct tree or a quad tree, right? We're just subdividing space, and we have kind of a node-like structure. Conceptually, we have a node-like structure, but in the code, everything's going to be just flat arrays. Yeah, so let's get to it. Yeah, let's burn everything to the ground. The first thing we want to do is we want to figure out how are we going to store tile information. And it looks like we can store tile information in a buffer object. I want a tile map that has 512 by 512 tiles or slots for different tile values. I want that many. I want 512 by 512 unique tile values. And the reason for that is, without getting too much into it, is because the 64 by 64 by 64, that is equal to 512 by 512. I've already done the math. And I'm already coding something that has a 512 by 512 chunk of texture memory to store tiles. So if I make a voxel engine that the map is 64 by 64 by 64 voxels, then I can reuse a lot of the code that I have that works with like a 512 by 512 texture. But now one of the problems though is, okay, if that's what we're going to do at 512 by 512, and that's the texture we're going to store all of our tile values in, well, this image right here is 722 by 281, and the buffer size on Shader Toy is based on the image size here. So one axis is less than 512 here. How will I fix that, right? How am I going to fix that? And one way you could fix it is you could just reinterpret 722 by 281 as a linear array of pixel values and kind of like remap it onto 512 by 512. That's one way you could do it. And with that, I believe let's take 722 times 281. So 722 times 281, and then if we divide by 512, do we get something close to 5? What do we get? So if we divide by 512... Okay. And if we divide by 512 again... So that looks like that's also a no. Let me try this. Yeah, even if we were to remap all of the pixels in 722 by 281, that would still be less pixels than 512 by 512. So, what I'm going to do is I'm going to only use a 128 by 128 block of the texture memory. So very conservative, right? Because 128 is roughly half of the smallest axis here. And we will use, we will remap that to be like, we'll use the, we'll think about the bytes of each pixel, right? Usually you have R, G, B, and A, right? And we could think of that as 4 different bitmaps, right? We could think of it as grayscale bitmaps, right? So we could think of, instead of, if you have a 128 by 128 bitmap, you could think of it as a full color bitmap, or you could think of it as 4 monochrome bitmaps stuck on top of each other, right? There's the R, G, B, and A channel, and you could just interpret that as them as grayscale, and interpret it R as a 128 by 128 bitmap, G as a 128 by 128 bitmap, B as a 128 by 128 bitmap, and alpha, finally, as a 128 by 128 bitmap. And if we think of it that way, then with 4 128s by 128s, we can build back up to a 512 by 512. Or, no, because I'm not doing my math right. No, that's wrong. I would need 256. Right? Because, yeah, 250, yeah, 5, yeah, because, man, that would have been a mistake. Yeah, so 512 divided by 2 is not 128, it's 256, right? So, same concept. 256 is still less than 281 on this monitor. If I resize this, do we ever get something that's just way too small, or is there a minimum size here to this shader? Yeah, so it looks like, however Shader Toy works, we're never going to get anything less than 281. So we can make use of that by creating that 256 by 256. We'll only use 256 by 256 pixels of the texture of the buffer, and use that to just store tile map information. And before we get into any of the 3D stuff, we need a good foundation. We need to figure out how we can set up a project and oh, actually, did we not save that there? We need to figure out how we can set up a project. Hold on, Control A, Control copy. Hold on, sorry. We gotta set up a project and just figure out how we're going to get the inputs for tile setting using the mouse, like being able to click and set tiles. And it's not just that I want to be able to have that interactivity, it's also that I want to stop hard coding my tile maps and actually use like a texture object. Because 64 by 64 is 64 by 64 by 64 is way too much stuff to just hard code in the source. So we shouldn't do that, right? Let me save this. Okay. So let's figure this out. So I kind of know how this works already. So down here, you can't really see that, can you? Let's see if we have a. Can we do like a full screen top, maybe top view? Let me see. Hold on, I'll add sound first. Okay, so sound is. Do we got sound? Okay, we got sound. Let's add let's add full screen. Okay, so in Shader Toy, you have this channel here, and this is where we're going to store our texture information. So we're just going to go to channel 0, and we're going to hit buffer A, and then we have to hit the X here, close the window, and that's going to let this shader sample from buffer A, right? So this channel 0 is linked to buffer A, but we also need to open up a tab for buffer A, or is that exactly how it works? I don't exactly know what I'm doing. So, no, this is buffer A. So in our image tab, we need, in channel 0, we need to add this buffer A here, but then also we need to add another tab that is actually called buffer A, and then we got to go down in the channel here, and we also have to use buffer A here. And that's like the minimum for the setup. It's kind of, well, not the minimum, there's still more stuff we have to do, but that's like the non-code portion that kind of got me screwed up. So let's go over that one more time, because I did not do that very well. So let's go to Shader Toy. Okay, and let's just do new. Let's do the new tab up here. And in our main image right here in this image tab, on channel 0, we're going to click channel 0. We're going to go up to buffer A. We're going to just select this A. We're going to hit that A. You might notice under here it's been set now. And then we're just going to hit this X and close it. Now in channel 0, we have this buffer A buffer. And the buffer is exactly the same size as our image, from what I understand at least. Then we're going to create a new tab right here. So we're going to hit this plus, we're going to hit buffer A, and now we have a buffer A thing, right? And then we don't want to forget that we also, in channel 0, want buffer A selected here. So same step as the previous tab, go to channel 0, hit buffer A, close it. So on both tabs, we have this buffer A in channel 0. So in here, and in here, and it's important that it's in both. So, with that, we need to get some feedback on how on this buffer, right? Like, we need a sample from this buffer so that we know that we're actually able to like get stuff from it, right? So, what we're gonna do is we're gonna take the. We should be able to just do a Texel fetch over here. So I'm going to actually move this back because I don't have enough contrast on this monitor. So I'm going to move back to the other view. So go back here. We're going to move this back over to my other screen. Okay. So in the shader code, in our image, oh, that's weird. In our image, we should just be able to do texel fetch. So let's go do... So let's do a vec2 fragcore.x minus 0.5 fragcore.y minus 0.5 to get rid of the pixel centers, because we're going to do a texel fetch. And then vec2 color equals texel, I think it's called texel fetch like that. I could be wrong. And then we'll use the coordinate, and then I think that's all we need, right? No, we need I channel 0. So I channel 0, and then the fragment chord. So, and let's give that a run and see what we got. I'm sure we might have screwed something up, but let's just see. It's not giving us any feedback. Texel fetch, no matching overloaded function. So let's look at how you write texel fetch. Texel fetch. Shortcuts. Reload my shortcuts. Texel fetch. Okay, so there should be like a texel fetch command. I thought it was just texel underscore fetch, but let's look for it, because I guess it's not texel underscore fetch. Okay, it's a camel case, so it's going to be texel fetch and level of detail. So we can do, I believe 0 is the... Oh, if present. So we don't have to do the level of detail. We can just do, okay. So let's try texel fetch. Texel fetch in our code up here. We're going to try that. We're going to rerun that, see if that works. And... so... Shader Toy has really been kind of crappy lately, where things aren't, like, refreshing. Texel fetch, sampler, and... Okay, let's look on Shader Toy for shadertoy.com. And let's look for let's search for texel fetch. And see how they're doing it on Shader Toy. And maybe we can figure out what to do just by looking at how it works in Shader Toy. If we can... Texel fetch channel and IZ. What's IZ? Is IZ the level of detail here? Yeah, so I thought I channel 0. Yeah, so it kind of looks like What's IZ? Control F, IZ. Yeah, I don't know if, that's a LOD. I channel 0. Okay, so let's go over here. And I channel 0, and then do we just need to include a 0 for the first LOD? And this is annoying as hell. This is not... Do I have to go back and forth between tabs now for it to update correctly? I don't know. Texel fetch. No matching overloaded function found. Dimension mismatch. I'm gonna get out of my snow pants here for a second. Texel's fetch. No matching overloaded function. Dimension match equals... Oh, yeah. So that'd be a 3, Control A, Control... Yeah, Texel fetch. No matching overloaded function found. Okay, so obviously I don't know how to use Texel fetch. So let's rectify that, I guess. Texel fetch. How the hell do you call Texel fetch? So, oh boy, that's a lot of stuff. That's neat. How to use GLSL Texel fetch. Sampler and IVEC, and then... Oh, it's an IVEC, yeah, of course. So, we're gonna take, we'll do IVEC. Should be IVEC 2 constructor, and then... We'll take the math here, and we'll do int, and we'll convert that to int as well. Let's just try to get the first part working, because... Okay, so IVEC 2, and... Okay, yeah, that's kind of what I expected. So... Okay, VEC 4, so C4D. Color 4D. And we're gonna make some defines here. So we're gonna say, define, IVEC 4, IVEC 2, IVEC 2, and then, define, okay, and over here, instead of that, we'll do IV2, and then IV2, and then define... Can't really see this, can you? So over here, we're going to define I32, and we'll just use int. Okay. and just make it a little bit simpler for us. Rather than having all these weird things. I don't know, I just don't, I like things to be kind of normalized. So let's run that and see if, okay. And fragment color, we're gonna do color 4D. Color 4D. And then we're gonna start doing this in my other editor because this is really annoying. So this should be a vec4. So, define v4, vec4, and let's run that. Okay, there we go. So now we got some blue. And if we look at the buffer, if we look at this buffer here, the buffer is actually set to have a just a solid blue color. So what we're going to do now is we're going to take this, let's take this and let's start over now. Let's just call it SDF 018, and we'll add these links later. Hopefully no one claims them as I'm working on them. That would kind of suck. But no one's watching this anyway, so hopefully that doesn't happen. Okay, so agenda. Store 512 by 512 values worth of tiles by splitting the ARGB components. Okay, so now that we're thinking about that, we should also look at, I need to look at, okay, so I got all these things here, and I need to add, if we look at my image code, we need IV2 for IVEC2, so let's add that somewhere. We can just add it up on the top, and we'll call this SDF 00018. And we need, what do we need here now? What is next? We got a little agenda, we got our little header, we got nothing down here now. D is for data. I'm going to try to be as terse as possible, so I'm going to actually do macros. And these are kind of like your boldest lines, so the boldest, most obnoxious lines I actually make with the actual letters. But I think it still would help to not like waste any space by putting comments in other places. So let's try to be a little bit more cleaner with the way we do this than with the way we did it last time, and try to be just try to make it more streamlined. Like, yes, we do have a lot of vertical space because of the way I organize my code, but let's just try to be cleaner with it there. So I still like this easy source, direct source. So let's just SDF 18 is starting over through SDF 0 and 7 inlet. Okay, so we're starting over, and because there is a lot of so how are we going to organize this now that the code exists in both a buffer and an image, right? So we're going to need a we're gonna keep it simple. Or instead of this easy source, direct source, we're gonna keep the we're gonna do easy source, direct we should probably just think about this kind of code here, and it does make sense to have the redundancy of the easy source, direct source. You know, like what if something happens to tiny URL? Then we can go back onto the paste bin. But no one's going to remember the pastebin URL because it's kind of convoluted. So let's say the most important parts are the source, source demo, and we'll do like a setup video. And we'll do like a tinyurl.com/sdf18. And we'll do like a small setup video for how to make this work, how to like get this code to work. And because honestly, getting started is the hardest part. Like if you've ever, yeah. So we'll have a setup video as well. So easy source, easy demo, and setup video. Source code. Live. Source code, live demo. Source code, live demo, setup video. So yeah, because now this has to be source code. So we really need source code 1 and So I guess we have a live demo, a setup video. We need source code image and source code buffer. And so really we want to take all this, and we're going to have to like reorganize how we're doing this. So save this as like SDF 018, and this will be the image dot image dot dot underscore. And then so if someone just checks this out, if someone just checks out SDF 18, it should just lead us to the basics, right? Image, buffer, demo, and setup, right? So very consistent. So let's go with that. Save that, and then new. We need the same thing, but we need the buffer code. So we'll do SDF 018.buffer. Okay, so we got image, we got buffer, and we can take a lot of this and we can copy paste, and we should probably have yeah, I'm actually fine with that. That's fine. So with the buffer, we'll take the buffer code and let's actually do something like this. So functions below do not indent outer scope is what we could call it. And the reason why we're not going to indent the outer scope is because the section of functions can honestly get very, very long. And so we'll just have a very long strip of indentation that just is just wasted space. Like, if you go 1,000 lines at the same level of indentation, the indentation eventually just becomes meaningless. It's kind of like with Java programming, how you usually have a whole bunch of meaningless indentation in your code, because everything needs to like have this like namespace and class or whatever the hell. We don't want to waste any indentation, so we're not gonna. If we're in the functions section, we're not going to indent. So functions, below, above, right? We could do like this. I don't know, it doesn't really matter there. So we have like a nice little organized thing. Let's just paste that into that is a lot of clutter at the head, but it's not too bad. Then in the image, we'll do the same thing with main image. We'll take this thing that we're working on, and we'll paste it in there, and hope that we didn't break anything, and I think we already did. Control Z, Control Z. Let's, the image code is copy. Let's actually paste the image code in there. And let's take the design that we used for the functions section, and let's put that in there as well. Okay, and we have some problem with our indentation already, where we're going off the screen, so let's clean that up a bit. Let's IVEC2, we can move these defines outside, because they're top level macros, so now, macros like this, I usually want to undefine them as well. Even though it's GLSL code and these will never need to be undefined, I like to just be consistent and have macros that I make undefined as well. So we'll take this, we'll take macros, and we'll undefine them as well, undef. Okay. So now we have this functions section, and we don't have anything in data. No data. Okay, so this is kind of bulky, but you don't have to pay attention to all of it. This is really all that matters right now. And so we're in the image. I'm going to paste that back into the image stuff. Make sure that that runs. Okay, that runs. Go to the buffer. Take our buffer code. Paste that into the buffer thing. Make sure that works. Okay. So now that we have both of those and they're working, we got this blue, this solid blue, and that is from our our output color is just this right here. So what we want to do is we actually want the output color to be a Texel fetch, I believe, yeah? Yes, actually we want the we want to take this color 4D, and we just want the output color to just so we just want to sample from ourself, and that will create some problems to where this will probably end up black, or it might be blue because it's already blue, but it's going to it'll create problems for us. So Texel fetch, and For that, we're also going to need to do the same thing for the fragment chord. So let's take that as well. And the code almost looks identical now on the main image and the, So now we just have two pieces of code that are identical for the image and the buffer, which might be kind of confusing, but let's just keep on doing this. Okay, so everything is blue, and I'm going to guess that in our buffer, if we get rid of the buffer, we'll see that color get removed. So I'm going to click the buffer and get rid of it. You can't see it, but I'm getting rid of the buffer, and if we scroll up, we see that it's black now. I'm going to re-add the buffer, and buffer A, and after re-adding the buffer, we should see kind of like a... We should see... we should probably still see black now, because the buffer kind of persists, or kind of remembers what happened to it, but we've kind of, like, by deleting the buffer and recreating it, we've kind of cleared out what was persistently there. So we need to figure out a way where we're going to determine we're going to determine how to know whether we need to clear the buffer or populate the buffer with new stuff. And one way to do this is we could see whether or not the bottom right pixel is black or not, and we could use the bottom right pixel as a flag. And I actually know that I want my voxel map to be not 64 by 64 by 64, but rather 63 by 63 by 63. I have a reason for that, which I might get into later. But that's what I want, so therefore I have some space on the extreme bottom right corner where I could set a flag pixel. So we're going to set some type of flag value. So we're going to use the bottom right as a flag value, and in the texel fetch, what we'll do is we'll say v for reset flag pixel equals and you know what, we're just gonna add a we're gonna try to be more terse and just add a key here. So we're gonna add a key section. And in the key section, we'll explain any of the variables. And this could get out of hand because we add a key and we keep everything really terse, it can lead to problems where it's like, I don't remember what any of this stuff does, and it's very hard to get back acquainted with it. But I want to keep reducing the clutter is just one of my main concerns, because if the more we wrap these lines, the longer the code gets, and then it becomes a nightmare to manage after a while. So RFP reset flag pixel. Okay, so RFP, and that'll be equal to a texel fetch on I channel 0, and we'll use IVEC2, and remember we're going to use like a 128 by 128 in RGBA. So we want the we actually only want to look at the alpha byte of this to determine if it's the if it's the pixel we're concerned with. So let's do this like that, and then we'll do U32 reset flag byte equals, and we'll take the we'll take the, so these are going to be, I don't think these are integer textures, so we're going to take the RFP dot XYZW. We're going to take, can we take the alpha? Can we do it like that? Maybe. I don't know if we can do that, because I think we can. I don't know. Actually, let's just do that to be safe. So W, and then divided by 255.0, or actually no, multiplied by 255.0, and then after that we cast that to a U32, right? And we'll add in our notes that RFB is a reset flag byte from okay, and if RFB greater than or equal to U32.1, the else. Okay, and so C4D is going to be a Texel fetch. Actually, no, it's yeah, else. Otherwise, C4D. This is where we're going to set the initial value, right? So if we set the initial output value, this output value is persisted to this main image because it's a buffer. And if we are in this initial state, we want to set okay. So on that last section is kind of tricky because we don't want to yeah, we're just gonna have to kind of hackishly do this. So this is where our flag pixel is, and if we're not on the flag pixel, we can just say that color 4D equals a vec4, and we can just do 1.0 for the red, and then green and blue and alpha, right? Really simple. And otherwise, we need to think about it for a second, and So actually, let's put let's fill everything. So let's fill everything with something solid. So 1.0, 1.0, and 1.0. Red, green, and blue. We're just gonna fill it all. And then let's kind of separate the alpha channel over there. And if it's... I guess it doesn't really matter, right? The flag pixel, because this will hit the alpha channel. And make the alpha channel 1. So that's fine. We don't really have to do this. So, so vec4, color 4D. And then we have these 2 places where we set color 4D, or 3 places. Fetch from what already exists. And also, since this is smaller, we should probably invert how we're doing this. So if this is less than or equal to 0, right? So we haven't... Or actually, oh, hold on. So if this byte is... If the byte is set, then we have information there already. So actually, if this is... if the flag has already been set, then we have some type of information, so we're going to fetch. Otherwise, we'll populate. So... so fetch the data or populate the data, right? Okay. And frag color equals C4D. Okay, so that looks good to me. Let's give that a shot. And what we're hoping for is to get a white back, right? We're expecting, because this is white, that's white, and we're expecting it to be this. But we'll see. Yeah, I don't know. Let's just try that and see if that works. Even if it works, it might not work for the reason we think it's working, so we still need to make some considerations here. So we did get white. Now the question is that what we think it is, right? So looking at the image, we're just doing a Texel fetch on the fragment, and Texel value to fragcore.xy. So I'm pretty sure that we're going to do this, and we're going to say that FPC. And actually, you know what we could do? We could make one key, right? Since we have all this stuff here, and we have all this clutter, but now we have this like SDF18 that doesn't really do anything anymore. We can just keep the documentation over here, right? And then we don't have to scroll back and forth. We can just flip to the documentation. So that might actually be nice. So FPC. Frag pixel frag chord Okay, so this is the kind of the key of what we're using. So we'll keep, yeah, we can keep like a nice little running index over on this page, and that could help us a bit. So, I see that we have changed both of these. Let's look at this frag chord. So F frag chord with a pixel center. So let's change all of these because the Texel fetch probably is assuming that there's pixel centers with these. So we need to remove the minus 0.5 because we're not going to use a discrete unit, but we also want to use a different variable if we're going to do it that way. So take that, and we'll take the, that's our buffer, so we'll take the buffer, we'll paste it, make sure that runs, we'll take the image, and in the image, take that image, copy it, and we'll paste the image. Okay, so we still have this white screen. Now the next thing we want to do is we want some way to make it so that when we click, we want... Okay, so we're gonna have to figure out some way to click and have the, a colored pixel in the buffer kind of like, persist into that buffer somehow. I'm not sure exactly how we're gonna do that. But that is what we need. We need some way to click on the canvas and have that set a tile value. So we know, so let's think about what we do know. And right now the image code should probably be just for rendering, and then the buffer code is what we're going to use for kind of like interpreting. Like, any interactive stuff is going to go into the buffer code. I think that's the way to... I think that's just the best way to do it. I don't know for sure because I'm new to this, but I saw some other examples where the mouse interactivity was put into the buffer section, and that kind of makes sense to me. So, let's figure out how we could do that. So, let's have a setting pixel section. So let's call... and then, okay. So we want to set a pixel or tile here. So if iMouse.xy, I think it's iMouse.w for down. So if iMouse.w is greater than 0.0, I believe that is down. And in this section, if the mouse is down, we'll change this to like a red or something. And we just want to try to get a pixel on the screen wherever we click, right? We want to just get some feedback to see, hey, when we click on the screen, we're seeing a colored pixel, great. And then we can kind of flesh out a more detail after we do that, right? So, all right, let's take this and let's take it and we'll paste it into ShaderToy in our I probably should reorganize this a bit so that you can actually see the ShaderToy code, since it's kind of like a lot of it is off screen. let me think here. So, I mean, if well, I guess as long as I scroll here beforehand, right? Because we have these two tabs now, and that makes it a little bit harder to follow along, I think. But anyways, let's take this buffer code that we just wrote, and let's go to the buffer tab, and let's cut, paste it in there. Hope we didn't make any mistakes. Surprisingly, I didn't make a mistake. That surprises me. And okay, so we clicked on the canvas, and the whole thing turned red. So, not exactly what I wanted, but nice to know that I clicked, it turned red, it stayed red, because that makes sense, because this is the Texel fetch we're doing. If that alpha channel on that 127 pixel has already been set. So that makes sense. What we're not doing correctly here is we have to remember that this is executing for every single pixel on the shader. So we have to be kind of hackish at how we're going to do this. This should only override if the mouse coordinate is on the current texel, right? So if the mouse is down, and if iMouse dot, I believe we just look at the X when the mouse is down. So we'll do like equals, and we'll do the fragment coordinate. Frag with a pixel center. So this is frag with a pixel center dot x. And I'm not going to indent any of this because there's nothing that needs to be in the middle of it. So if iMouse dot y equals fragment pixel center y. Okay. And then we can kind of just stack that like that. Okay, so now same thing, but we're going to guard it and make sure that the fragment chord is exactly where the mouse is when we do the mouse down, right? Since we already have red in our buffer, let's just change this and say red, green, and you know what? Let's just should I do that? Yeah, whatever. We're just gonna put some more macros up here because I don't want to overly clutter. No, that's not gonna... No. So I just don't like the way this looks here. Well, actually, let's just not use... Let's just do that, and then... maybe like that. I don't know. I'm being too picky. So let's just take that and paste that into our buffer again. And take that for a run, see... and I screwed something up. So I've been noticing lately that when I make a mistake, the... I'm not getting the feedback I need. I don't know if, like, ShaderToy has just been kind of weird lately, but... Right, nothing is red here, but the tab itself has been highlighted red here, and... So something is obviously wrong. Now, if I swap back and forth between these tabs... Okay, now I can see it. I have no clue why... you know, it was working... This is the browser I use for ShaderToy, so I don't know what's going on. I thought it was because my shaders were a lot of code, but now that I've started fresh again, I can see something is going wrong here. So, wrong operand types. So we got float and high p int. Okay. So... Oh, okay, yeah, so... God, we have a lot of problems, don't we? Let's make sure we understand what Texel Fetch does, because maybe Texel Fetch is supposed to be on, is not supposed to use the pixel centers, so let's look that up really quick, because maybe I don't understand how Texel Fetch is supposed to work. So, Texel Fetch GLSL. How to use GLSL Texel Fetch. Does it use... Okay, well, it uses IVEC, right? So if it uses IVEC, then I'm pretty sure it's not using pixel centers, right? And if you cast a fragment chord to an integer, it's going to truncate the decimal part, so the math will just work out correctly. But, okay, yeah, so I need to think about this. I'm kind of like, what do you call it? I am second guessing myself again, but you know what? It actually needs to all be this, because we're going to use a fragment chord with a discrete unit, and we're going to minus 0.5, because these are our Texel chords, and because we're using Texel Fetch here, right? So let's save that, and then let's go over here. Same thing, we're going to go minus 0.5, and we'll change this to FC, because this is going to just be our frag chord, where we think of it as having discrete units. So that I try to think of pixels as just slots in an array, or these cells that they just have. I try not to think of pixels as having... I don't know what I try to think of pixels as. I don't like to think of pixels as having internal coordinates or even thickness, right? But I do like to think of them as, like, squares. I don't know. I just don't like using floating point for pixel values unless I really have to. So, we're gonna put that back to FC for a frag chord, which I use this variable for when I'm talking about pixels that have integer values. Okay, so over here, have we changed everything back? Yes, we have. And it was this part, the iMouse, that we have the data types wrong. So iMouse, I believe, is a float. And, you know, we can just round that down, right? If we're so close to where we need to be when we round the mouse's floating point down, then that's good enough for me, right? So iMouse should be in terms of frag chords. We just gotta round that down, and it'll tell us which pixel we're over. So let's do that. And actually, let's be consistent and use our type def, so let's use I32. Okay, we'll copy and paste all of that into our buffer, and hope that that is all correct. And that's all correct. We'll go back to our image, and we'll take that, paste that into the image. Okay, so we didn't make any syntax mistakes. Let's go up to this buffer now, and let's try to click and drag and see if we have anything. And we have absolutely nothing. Oh wait, yes we do. Never mind. I'm just okay, so it's not dragging, it is clicking. So is that a click? I still don't know how. I'm still not well acquainted with the mouse stuff. So mouse W, and then maybe it was Z for down then. because I guess W must be click, so X, Y, Z, and W. So let's change that to Z really quick. So if I change to Z, and I give that a run, oh, so this is a problem. I need to, so having 2 tabs is really annoying. So now I pasted it in the wrong tab. So you must give your, oh, I did, okay, so in the buffer, let's go into the buffer, let's paste the correct buffer there, let's run that. In the image, there's nothing in there anymore, because I deleted that out of there, because I'm having a problem managing these 2 windows here. Okay, so now we've put that back in there. Let's look at this now. Okay, so now we kind of can click and drag. Okay, that's much better. So so that's mouse down. So now with the mouse down, we can kind of see that we're like adding pixels into the buffer just by being able to hold the mouse, and it's just going to put it one-to-one exactly where it is on screen. So now we have some type of confirmation that we can get pixels into, that we can kind of store pixels into a buffer, and that's actually a good checkpoint, right? We have this checkpoint where if we click, we can get some pixels there, and we kind of verify that they're there. So that's actually a good checkpoint. So let's look at what we have. We have kind of this key here. Now, FPC, I don't know if I really like FPC, but you know what? I do like that it's visually different from right, F and C are in the same positions, and then there's just a P in the middle or not, depending on if it has a pixel center. But I also use P for, I also use P for percent. So I almost want to call it, so, you know, I'm going to say avoid, and I'm gonna rethink this. So FPC looks too much like percent something ... Use FCC instead. So I do like the fact that it has the same letters, but then there's just a different letter there. I do like that. But this is confusing me. So frag chord centered. So we'll say frag chord centered. Frag centered chord. Alright, so we'll do FCC instead, right? Yeah, I would rather use that, so I'm just trying to clean this up. So over here, anywhere we see FC, well, actually, that's what we're using there. And FC, we're not even using that right now. RFP, RFB, okay. Sure, okay, let's take all that, and let's just put it into the places it needs to be. Okay, so those are where they need to be. And we got this little thing that's working, and let's name the shader, and let's just keep our convention of tinyurl.com. tinyurl.com/SDF. Even though there's no SDF code in here, the goal is to like build up a voxel renderer that's using signed distance function. So we're just gonna stick with the SDF prefix and just kind of keep that ordering. So we're gonna do SDF018, and that will lead to do we actually want to lead to this main page that just kind of like has all the information? Yeah, that kind of makes sense to just always lead to here. And then, because we never know how many different files we're going to have from now on, now that we see that we can have different types of tabs for different types of code. So it'd be easier to always route those tiny URLs to here, and then we have these URLs here. So that makes it a lot of extra work to like organize this, but I think it's worth it. So let's go and put that all where it needs to be. So we'll go to pastebin.com, and another thought here is, though I do like these being just the tiny URLs right here, because I don't have to really maintain it, right? I don't have to like cut and paste all the different URLs I'm gonna get when I create the resources. If I need to increment this for the next one, I'll just take this and change the 8s to 9s, right? And that'll be really easy on me there. But usually I want to keep some type of notes file where I have the exact URLs rather than this. So since this kind of routes to everything, I think it would be nice to organize it so that we have the indirect URLs and the direct URLs, right? So we could actually kind of segment this and say that direct URLs below, and then for the sake of good advertising, we can say easy URLs below, right? So we have the easy URLs and the direct URLs, right? And then we can kind of, since these are technically the same section and they're kind of like these subsections, we'll kind of like use a dashed line to segment that. And we can reuse this kind of template over and over again. So, okay, so with our direct URLs, it's going to be for the live demo, that's going to be shadertoy.com. So this is shadertoy.com/view/something or other. This right here is pastebin.com/something or other. Over here, the pastebin.com/something or other. And then this one's actually going to be YouTube, so we're going to actually start recording short videos of just the setup for this, because as somebody who's not familiar with ShaderToy, I found it kind of annoying that I had no clue how these different buffers worked and all the different controls. So we want to keep some type of YouTube URL. So YouTube ... and we'll figure out exactly what the what those values should be. Do we like that? Is that... Yeah, I think that's good formatting, so let's clean that up a bit. And let's make this first entry. So, am I logged in? Okay, I'm logged in. And this is GLSL. And the paste name is SDF018, and we'll create this paste. So this is just a lot of mundane maintenance type stuff, but I think it will be helpful. So pastebin.com, and that is Oh, okay, so, so we actually need a self URL, right? So this is, that is kind of... That is kind of annoying that we need, like, this... That is kind of... Oh, whatever, it's all there, right? As long as it's all there in a nice table and we can kind of see where it is. And we have this hierarchy where, yeah, that's fine. I mean, it's kind of more work than I would like it to be, but that's okay. So, so www.tinyurl.com, and we're going to take this SDF18, we're going to go to tinyurl.com, we're going to enter that, and that's not the correct URL. What the? Let me refresh. So, copy. Sometimes my clipboard does weird things. Oh, I see. Okay, in tinyurl, I'm going to say SDF-018. Okay, so now we have that set up. We need the image code, so we're going to take this image code, and we're going to do a new paste. We'll paste the image code, and syntax highlighting, GLSL, paste name SDF018, and make sure it is the image. Yep, it's the image. And create new paste. Okay, so now we have the paste bin for the image. And we can put that in this, the direct URLs over here. So now we have the image. And for the buffer code, let's take this buffer code. And let's do another paste. But before we do another paste, we need to... hold on, so... Did I already... Let me edit this. Yeah, this is gonna be... Okay, yeah, that's good. So we're gonna go make a new paste. This is... Hopefully I'll get used to this workflow, but I've noticed that the amount of administrative overhead is a little bit more than I am... I'm not really a fan of it, but if it makes it easier for people to find the stuff and get to it, then I think it's worth that extra effort. So we're going to call this one SDF-018, and we'll call this buffer, right? So SDF-018-buffer, and we're going to create a new paste. Okay, and then we're going to take that URL, and we're going to go over here, and we're going to paste the buffer code. So now we have all of that, and I guess what we should do is we should probably get all of the direct URLs first, and then we can, once we get the direct URLs, we can get the we can create the tiny URLs, just so we have kind of a process, because I believe I made the image tiny URL, but I haven't made the other tiny URLs, and if we don't do this in a batch processing sort of way, we're going to lose track of what we did, when, etc. figuring out the basics of we will. Okay, so I'm gonna label this shader and give it a little explanation. Figuring out the basics of how we will set tile values into how we will interactively set and get tile values. Or usually I use the word put and get rather than get and set, just because put and get are visually they are more different than set and get. Set and get only have a one-letter delta, right? It's the difference between G and S, whereas put and get have a two-letter delta, right? P and U are different from G and E, right? So the only similar letter with get and put is a T. So I like to use put and get rather than the word set. Also, set could be like a mathematical set. So I just feel like set is a very vague word, and I just like the word put better. Okay, so we're going to keep this unlisted until we've set up all of the URLs, and also we want to reload this and see if this actually works properly after we reload it, because I don't know if that's true or not. So unlisted, let's hit the submit button and see what happens. We gotta assign some tags, so we're just gonna say pixel setting pixel setting tile map basics tile map basics. Pixel setting, tile map basics. Okay, that's fine. So we have some tags. Let's submit that. Okay, so we have this white screen. Okay, the screen's white, but when we click and drag, we get those little blue dots. So that's awesome. We might want to update the description. Click and drag on the canvas to set pixels. Right? We might want to update that description, and we'll save that. And then we also might want to update the description in this code, and we also might want some type of way to so I think the agenda, right? I don't think I want to split this agenda stuff into all three of these files. I think it would be better just to have the agenda kind of here. And we could actually, we could still keep these URLs, because we definitely want, like, ways to get back to the origin of everything. But as far as these, like, little agendas, let's take these little agendas and let's put them in kind of like this main thing, and so let's make an agenda section. Let's just make so and for the agenda section, let's kind of do it similarly to how we did this here, right? Let's try to keep a similar nice looking pattern. And okay, about voxel engine work. So the next question is, what about like how to use? So we have the little agenda and whatnot, and the agenda is kind of like what our goal is, but it might not be where we currently are. So over here, we should probably have instructions on how to operate. But I do like kind of keeping this like that. And hopefully, like, making more of these files will be a little bit easier after we get this first one down, but we've just kind of shaken up the format that we've been using, just because of how we're going to have all these different resources. So, I guess this is most important because we want people to be able to find us, and let's just make an instructions section. How about that? Instructions, right? The thing with a hierarchy is that you gotta choose what is most important, right? So no one reads the instructions anyways, so why put the instructions at the top, right? So hierarchy should probably be advertising yourself first, giving someone all of the other useful resources, all the useful information, and then instructions will come next. So I think that's how I want to prioritize. And then in the instructions will be duplicated in both of the files. And what about knowing what the file is? So I also really want to know, from just looking at the source code right away, I actually do want to know what the file is. So, this file, yeah, because when people save this to a lot of this, like when we look at this stuff and this stuff, because the header is so similar, we might get confused when we're cutting and pasting it, right? So we should probably have the file. So this file is sdf018.buffer._, right? So just kind of like tag that. And yeah, I think that's important just to have as the first line, so that when we're flipping through here, because yeah, it looks almost identical. So let's dot image. And then we'll do the same thing with this. So this file, that way we have like something unique. There we go. So now we can see what each file is with a little tag, and that way we'll instantly know if we pasted it in the wrong spot, right? So that's going to that should be helpful. What is next? Okay, I guess we can just put the instructions in here now. Instructions are click and drag on the canvas to set pixels, right? And even if somebody just clicks, it'll still do something. So let's not explain what click and drag is. I think everyone... okay, hold on. If we're doing shader code, I don't think we need to explain click and drag as, hold the mouse down and move around. I think click and drag will be explanatory enough for anybody who is viewing this type of content. So let's not get overly verbose with those instructions, because our audience already understands that well enough. Okay. So that looks good, and the way we formatted this, right, we've only used the tiny URLs in here. We don't have to worry about editing these later in the paste bin, right? Well, we still do, because we gotta, because we've changed them. But let's update our image on ShaderToy. And then we'll update our buffer as well. And because this takes so long, we'll try to, I'll try to get all of this stuff kind of... The next time I do one of these streams, I'll try to get all of this stuff kind of squared away before I even begin, because it's like a lot of... could be a decent amount... This could be like 30 minutes of, you know, administrative effort to just get all these files in order. So, click and drag on the canvas to set pixels. So that description, that looks good to me. We'll save that. And now we need to update all of our paste bins. So let's go to the paste bin URLs, and we do have a self URL. What about this? Do you have a self URL here? Image buffer demo. So I guess that SDF18 is now kind of like a documentation, right? Because now do we want to call self documentation URL then? Do we want to yeah, I think if we call it documentation URL and then you go to that documentation URL and you end up at the same place, then that's kind of self-explanatory. Huh. Or we could keep self URL and documentation URL. All right, we could keep documentation URL as well. And then tinyurl.com/sdf-018. And then the same thing over here, right? We could keep just the self and the documentation URL. We could just keep them the same because of which file we're in, right? And... right? Now, if we're going to do self URL, let's be consistent and do that in the other files as well. So I promise that the next time I do this, it's not going to be so much administrative stuff. It's just that I'm kind of reorganizing how I do this, because these extra tabs in the ShaderToy have kind of thrown a wrench in how I was doing things, and I need to rethink kind of how I'm organizing everything. So this could be, so same thing, source code image. So we just want to take one, two, three, four, five, six, and right. Okay. And this one is buffer. Okay, so another thing is, if we have everything, if we've been very meticulous about how we've been doing this, then we should kind of see everything kind of remain pretty much the same at the top and just have certain values kind of animating, right, when we go back and forth between our tabs here. And that is almost what we have until we get to this one, right? Because we have the easy URLs and the direct URLs. But we have 6 sets of URLs, 6 sets of URLs, and 6 sets of URLs. Okay, so that works for me. This is buffer, this is image. Okay, that's good. So now let's update. Okay, and we'll update the buffer again. So I'm going to take this, paste it in the buffer. Or, no, I'm not going to take that in the... Can we reorder these tabs? Or is it always buffer then image? I guess it's always buffer then image, so let's put that in the correct order up here. So buffer then image. We're going to put these tabs in my editor in the same order that they are in ShaderToy. So when I'm cutting and pasting the code into ShaderToy, they'll be correct just because I paid attention to what position they were in, right? Okay, there we go. And we'll save. And now let's re-update everything. So let's go to our Pastebin URLs. So we have the documentation URL. So let's go to that. And let's just take all of this. And let's edit this. So is there not a... Where am I? Okay, we'll edit it. Okay, and it looks to edit it, we just gotta put the edit word in front of the URL, so that might be a little bit easier if we kind of remember that for next time. SDF18, save changes. So then, documentation URL, then we're going to do the source code for the image. So let's do edit / and the image URL. And then we will take the image code, copy, and just paste that in there. Save changes. And another thing I'm realizing, I'm not going to change it in what I've already pasted here because I've done enough refinement and I'm really just sick of it and I want to be done. But in the buffer, let's buffer, so source code buffer. Okay, we're going to take all the buffer code, and we're going to Control A, and we're going to save the changes. So we need some more consistency here, and I notice we have documentation, image, and then buffer, but in my tabs in my editor, I have the documentation, the buffer, and the image. So we should make sure that in the comments here, we kind of put those in the same order so that when we're flipping through it, it makes it a little bit easier. So we have image, but we should do buffer and then image. So buffer and then image, BIDS, buffer image demo setup. That's kind of a nice little acronym there. So we'll stick with that acronym, I guess, because it's in the order. And BIDS, okay? Yep, and same thing here. We want this to be in that order as well, just for consistency. Buffer, image, and demo, and setup. Okay. So now that we have that, let's go to the different tiny URLs. We'll just go to the different tiny URLs, and if they don't exist, we'll create them, right? So this file is SDF18, and that is the case. So let's go. So it was good that I put that header there, because now I can easily see that when I do the tiny URL, I can instantly see that I'm looking at the right thing right here, as well as I can see the right thing here. So if I make any mistakes where I cut and paste on the wrong thing, I will easily be able to see that I have made that blunder. So if we go to sdf18/buffer, there is nothing there. So let's go to tinyurl.com and actually make that entry. So the buffer code, so buffer, let's highlight both of those to make sure that we don't make a mistake. Because if we screw this up, we're not going to get a second chance. So take that buffer code. We're going to visit it on Pastebin first to make sure that that is indeed the correct URL. And it says it's the buffer. It says it's the buffer, so I'm convinced that that's our buffer code. So let's paste that buffer code, and then we'll do sdf-018-buffer, right? And then we'll make a tiny URL. Okay, SDF018 buffer. Okay, let's go on to the image and make sure that we have that. So in the image, and did I already do that out of order? It looks like I already did that out of order. Or, wait, BIDS. Oh, this is not in the correct order. That's why. So let's move that around. Okay, BIDS setup video. Okay. So in our image, let's go here. Make sure it doesn't already exist. I'm pretty sure it does not exist. Doesn't exist, so let's go and change that. So here is our image Pastebin URL. Okay, this file, sdf.image.image. Okay, so I'm satisfied that that's correct. I'm going to paste it there. I'm going to do sdf-018-image. And make tiny URL. Okay, cool. So I got the image URL. Let's go to it. Make sure that it, if we screwed up, we'll just be in trouble. We just want to be very careful with this when we're doing it. Okay, so the actual shader, we do have the shader now. So let's take that shader code and actually put that in there, right? Okay. And then for that, let's go to ShaderToy, and I'm going to ShaderToy in my top monitor just to make sure that that looks correct. I kind of assume everyone knows how to use tinyURL and Pastebin, so that's why I'm not bothering to switch screens to it. But if you don't understand how Pastebin works, then, I don't know, I'm sorry. So that's actually not what I would have expected. Hold on, so am I missing a letter here? Oh, okay, no, it just took a time to load, so okay, yep, so that's good. So let's take that, we'll go to Pastebin, www.pastebin.com. Okay. Yeah, or not Pastebin, www.tinyurl.com. Okay, paste. And we're gonna call this one, this is the actual demo, so we're gonna call it SDF-018-demo. SDF-018-demo. Make a tiny URL. Okay, we got the URL. Let's take that, check it, make sure that it actually goes to ShaderToy. Okay, that's in place, and now, like, making a little YouTube setup video. So we should probably stop the stream and start a new stream once we're ready, and figure out how we're going to do that. So, let's see. All videos should probably start with all videos should probably start with an example of what's going on, and then they should go on to explain the setup. Because I never read a tutorial unless at the very beginning of the tutorial it kind of tells me like what I'm gonna make, what we're doing, and so we should do the same thing. And we should probably readjust some of our. We should look at some of our cameras here, and figure out what to do here. So this top full screen is probably what we want to. We probably want to move this top full screen up to. Okay. Alright, so yeah, we're gonna try to record like a very small introduction on how to use this. And we'll kind of go from there. And can we do a... We should probably do a full screen section for the shader, because we have the shader here, but we should probably have a full screen scene. So I'm going to add another scene to my broadcasting software, and then I will start a new stream for recording the tutorial on how to set this up, and we'll kind of continue from there. So let's see. New scene. Full screen shader right monitor. I'm gonna have to add some sound to that other scene. Hold on. Alright, we got sound again. And the monitor, let's use the right monitor, and then we're gonna have to crop it. So display capture, add source, and new source. Okay, let's crop this. Yeah, let's crop this. So let's go over here. Okay, and let's, did we break this already? Is this broken? Because the screen is black, so that's not a good sign. Well, I guess it's good we tried to, I guess it's good that we, tried to, that we've reloaded it a few times. So, I don't know exactly what's wrong here, but we'll try to figure it out once we, get this full screen, I guess. Once I've cropped this, we'll go back to looking at that. So let's, do, what, maybe 15? Top, maybe 300? 200? The right, probably another 15 maybe. Maybe a 20. And then the bottom, like a 600, 900, something ridiculous. So I think keeping the URL in view for where to go, I think this is useful, keeping that right there. So I think this is good for full screen. This context right here I think is useful. So let's just take that and we can kind of like just stretch it over the whole screen. And we have some extra stuff, so I don't know what we're going to do with that extra space. I guess we can adjust the cropping. So let's look at our filters and let's adjust that cropping a little bit so that we can get more of that space down there. So the 810 we were using, let's just try, I don't know, 790 and 780, 760, 750. Yeah, I might even be able to get those tags in there, which might be nice. Or not. 750 about, yeah. Yeah, we can worry about getting that better later. I think that's good enough for now. It also allows us to kind of like scroll down here like that and kind of see the code a bit. So that's I do like that then we can actually think about why is this wrong right now. Oh, and it's obvious why it's wrong. So when we click between these two tabs, so you can see it now that we've... So we decided earlier that we were going to always say that have this like this file tag at the top of the source code, and that's good because when you go between the buffer and the image, we see that some of it's different, but they both say that the file is the image file. So somewhere during our cutting and pasting from our main editor, we kind of like screwed stuff up. So let's take our buffer code and let's paste it all in there. And then let's take all of our image code. Okay, we'll take all our image code, paste it in there. Okay, so now let's hit the save button, make sure that that is saved. And now we see that at the very top of our code, we have buffer in our comment and we have image in our comment. So we can see that those are the correct files easily. And now we have a white screen, and when we do this like clickety draggety drag, we can see that we got those pixel settings. So that's awesome. Because that's, before we can do any stuff with the tile map, I really want to be able to set the data for the tiles into a texture and do that all on ShaderToy, because I really like how ShaderToy is just really good for prototyping stuff. So now we have a way to get the data there, right? As far as worrying about how to abstract that data, that's like a different layer well, it's a different layer of abstraction, right? We need to just be able to prove that we can get the data and do something with it, right? So now we've kind of proven that we can do that, and we can go on to like more like tile map logic, right? So we'll do a very I think we should do a... So our voxel map, we want it to be 64 by 64 by 64 voxels, yeah, 64 by 64 voxels is what I want the map to be. And what we could do is we could make it so in our in that alpha channel in the alpha pixel on the bottom right hand corner of our buffer, the bottom right hand corner of the usable space that we're going to use, right? We're only going to use a 128 by 128 section of the buffer, just so that it never gets truncated by resizing the screen. In that bottom corner, we will do some bit shifting math on that alpha value to get other information, right? So right now we just use it and we see if it's non-zero, and if it's non-zero, we assume the data has already been initialized. But we also would like to check, what else do we want to check for? If the data is initialized, but we want to, we can just store some settings, right? We could store settings and the, yeah, we could store settings. I mean, that might not be the best place to store settings, but, is that really the way I want to do it? Yeah, I think that's the way I'll do it. And we can look at, right, we have 1 byte, right, because we're just looking at the alpha channel. And so we have these 8 different bits, so that's actually not enough information, is it? Or maybe it is. Let me think. So, we got 0 to 255. If we split that in half, we get like 0 to 128. Split that in half again, we get, sorry, 0 to 127. Split that in half again, we get 0 to 63. Right? So let's, let me make sure that that's correct, because sometimes I do really stupid things when I'm thinking of binary math. So if we break out our calculator here, and we do like B, can we just do B 1111 1 2 3 4 5 6? So if we use 6 out of the 8 bytes to decimal, will it query correctly, or do I have to get out the programmer calculator? Let's break out the programmer calculator really quick. So let's break out our like Windows calculator and think about this for a second. Wow, it does not like that layout. So let's go to the top full screen. Okay, so in programmer, and let's go to binary. Where's our like bit twiddling? Okay, so if we're only going to use these 6 bits, right? Then that's 0 to 63. And that'll work for us, right? So we want we want our tile map to basically be, it's roughly, our tile map's roughly going to be 64 by 64 by 64, but I'm actually going to make it 63 by 63 by 63 for a very specific reason for how I think things will fit together nicely. And I don't know if that's like misguided. It's just that I would like everything to have a definite center, right? And to have a definite center, we have to have odd numbers. Now, that could come to, like, that could be, I could be shooting myself in the foot. Like, we could, a week later from now, I could be like, that was the stupidest idea, and then we, like, throw everything in the trash and we try again. But, just from a design perspective and what makes things easy to design with, I find that, when I'm trying to make designs, it seems to me like the space is more efficiently used when there is when we have a center in whatever we're doing. So like a 3x3 bitmap and a 4x4 bitmap, the 3x3 almost has more utility because it has a definite center. And so even though it's a lower resolution, you can almost get more out of it, right? And a 7x7, same thing. A 7x7 bitmap seems to be, to me, from an artistic perspective, seems to be much more useful than an 8x8 bitmap because of having that definite center, right? Because in art and in, nature, right, everything has symmetry. So being able to have that center pixel in there, I don't know. There's something about it from a design perspective that I like. But from programming, it's worse for programming because it's not a power of 2. However, design-wise, it seems to be more friendly from what I have experienced. So I want to take into consideration the design aspects of this voxel engine while we're working on it. So, yeah, so 6 bits. We have enough if we do 6 bits. So of the alpha byte of the pixel at 127 in our texture memory, we can look at that byte and we can look at the last 6 bits of it, or the first 6 bits, I'm not sure, but we're going to look at only 6 bits of it, and we'll use that to calculate a number between 0 and 63, and that number is going to tell us what layer we're on when we are viewing or editing. So there's other things we might want to use. We absolutely need 1 bit as a data initialized flag. We could use 1 more bit for, is this a 3D view or a 2D view? And then we could use these 6 bits for what layer we're looking at when it is when it's a 2D view. So let's think about that. So in our documentation, we can actually go to our documentation and think about that. So we have key, and then we have so D for documentation, documentation. Okay, so in documentation, what I'm thinking is bottom left corner pixel 127 alpha. Okay, so So let's do what we were doing earlier, where we kind of like had these little hashtags. But I don't want to waste as much space, so let's do hashtag comments. Or actually, technically, it's extracted comments. Okay. So I think that, I think I would rather have it so where we can make better use of the space. So kind of like that kind of looks more ugly though, right? Because now we kind of have this extracted comments, and then we kind of have this just laying in there like that. And I'm not sure if that's how we want to go about it, right? Now, this file is no longer a source file that is ran in ShaderToy, but I still want to like format it as if it could appear in some source code. So we need these comment characters, so that way if it was pasted into some source code, maybe you just want to paste it down somewhere. Maybe you want to paste the documentation into the source code you're editing. We might want to do that. So I gotta say that even though we want to save space, I think that kind of looks like shit. So let's try to keep this kind of indentation level, and if we absolutely need more space because we have like some giant diagram or something, then we can kind of change that. But I think that's good for now, right? Bottom left corner, 127 alphabets. So, LSB. And let's actually just do this. So LSB, and actually, no, this is going to be the most significant bit, and this one is data initialized bit. So this will be our data initialized bit. Then this one will be 2D or 3D view of tile map, right? And the reason why we want this flag is so that we can kind of get started with the basics of like clicking and setting tile values without worrying about kind of the complexities of 3D voxel rendering, right? We can just do the two-dimensional rendering stuff, and it'll just be a lot easier that way, right? So 2D or 3D view of tile map, and then the last 6 bits is 1, 2, 3, 4, 5, and 6. And these 6 bits are used together to create a number between 0 and 63 to tell us what layer we're on. What layer are we on? Number in range 0 to 63. Right? So we have a number in the range of 0 to 63 that's going to tell us what layer we're on. And so we're kind of using everything very efficiently here. Let's change what screen we're on. Let's go back to the we got sound on this one. So we're using everything really efficiently here. Um, we're using, right, like, we can't, because of, like, a lot of people have this attitude of just refactoring willy-nilly all over the place. But I really like the quote of, I was watching a data-oriented design lecture, and the guy said, if you have different data, you have a different problem. And that's kind of the mentality I want to go with. And so we're going to think of a voxel map as being 63 by 63 by 63 voxels. And so we'll have one extra slot in our data, or like a little edge of unused voxels, because this gives us 64 layers, but we're only going to use 63 of those layers. But right, if we decided later that we wanted a voxel map that was 128 by 128 by 128, well, good luck, because we've kind of created a foundation that will not allow for that, right? But for my purposes and for what I want to do, I think that is a good amount of data to work with. Like, I don't want like a gigantic amount of data where it like, eventually an artist has to put meaningful values into the data set, right? So you want an engine design that's going to balance how useful you want an engine design that balances, hey, this looks awesome, and hey, it doesn't take a ridiculous amount of work to get to you want your inputs to be highly leveraged. You want the minimal amount of artistic input to go into your engine to get something awesome, right? The antithesis of that would be any modern day AAA titles where you have like these just very detailed models that an artist had to spend, a week or a month on, right? Like a character model, right? That could be like a week or a month for a character model. And, right, that's just a lot of effort just to get this one asset in, right? And as one person, there's no way in hell I'm ever going to compete with a AAA title. So we need to think of our strategy and think of how we're going to, like, best leverage what kind of resources we have, what type of time resources we have. So we should definitely not have resources that are that time intensive, right? So we want a design that has a good balance between a minimal amount of input to getting some good results. So, for example, a level map that is only 3 by 3 pixels isn't really enough information to like make a fun level, right? Only 3 by 3 tiles. Something that is 30 by 30 is pretty good to make a decent like one room level. 64 by 64 is going to be 4 times the effort of what that 30 by 30 level is, right? And you might want that 64 by 64 if the 30 by 30 was not enough room for you to create an interesting level in terms of tiles. But you don't want 1 million by 1 million, right? Like to go into the absurd upper limit, right? Because you would never have enough time to fill it all out. So you need to find a balance there. Okay, so we have this little documentation stuff. And we know what layer we're on. And that actually needs to come... This is actually the next thing we want to do. I just kind of put it in my notes because it's kind of like, that's where we're going with this. And I just wanted to do a sanity check and be like, is that possible to use that 1 bit for this kind of stuff? And we can kind of have a union style pattern here where, right, this bit tells us if it's 2D or 3D view. Well, if we're not in 2D view, we can interpret these as other things. When 2D view is on, is selected. So I think that 2D view should be the default, and I think that 0 should be 2D view. So I think 0, 2D view, and I think that 1 is 3D view. Okay. And then this is the LSB over here. LSB, least significant bit. Okay. That looks good to me. Let's go to Pastebin and edit that really quick. So I'm going to go to Pastebin, tinyurl.com/sdf-018. And we'll edit this. And we'll save our changes. Okay. Now the next thing is let's figure out how to do like a little tutorial. So we've got this. This seems to work. We've saved our changes. It's no longer black when we start. That looks good. Let's go to the full screen. Oh, that's top full screen. Where's my... Oh, did I move the shader to the top when I did that? Yeah, I think I did. So I think I actually moved this up here to the top. No, I didn't. Hold on. So let's... Yeah, let's save that. Save changes. Okay, that's... for a second. So let's log views here. I want to make sure that I lock down all of the sources so that I don't accidentally click and drag them and move them around. Okay, so that looks good. And then this is full screen shader right monitor. Okay, so it was the right monitor. Okay, yeah. So let's take that and refresh. Full screen. Okay, cool. So I think I'm about ready to do a little tutorial on how to get this working. Okay, so I'm going to stop recording and... Oh, I guess I can keep the stream going and I can just stop recording and restart the recording and then see where that goes. So let's stop recording.